This video is to help you work through the assignment, the Quantifying Diversity assignment, using the Simpson's Diversity Index. First of all, what is the Simpson's Diversity Index? The Simpson's Diversity Index is going to be a way that we can use math to figure out how diverse an assignment is. The diversity index is a number between 0 and 1, so it's a decimal. The closer that you get to 1, the more diversity you have. And that's good. We want a number closer to 1 because more diverse environments are going to be healthier environments. So in the diversity index, we use this equation up here. All right? So here's what some of these numbers mean. Little n means the number of individuals for each species, and big N means the total number of individuals in the entire environment. So in this scenario, there are 20 people in a classroom, and we're going to assume that there's no other living things in that classroom. So little n would be the number of individuals for each species. So this would be 20 humans, okay? And big N is going to be also 20 because there are only humans in this environment. There's nothing else. So big N would also be 20 total living things. All right, so then we're going to calculate the diversity index. So in order to calculate the diversity index, we take 1 minus the sum of all of the little n's. So this would be little n is 20, 20 multiplied by n minus 1. Okay, and we would divide that number then by big N, which is also 20, multiplied by 20 minus 1. So that takes us to 1 minus 20 times 19, okay, which is 380. Okay, so that equals 1 minus 1, which equals 0. Okay, so what this number tells us, and this number makes sense to us because in this classroom there is only one species of living things, right? So it means that this classroom, so a number closer to 0 is no diversity, right? There's no living things. If we have a number closer to 1, that means we have high diversity. So we want environments to be as close to 1 as possible to show how healthy that they can be. So here's how this works with your simulation. You're going to be given an environment and you're going to have to count how many species there are and then how many groups of species there are. So if your table on your worksheet does not have these 2 rows added on to that table, I would add them in because it's going to make organizing your data a lot easier. So this will be the n minus 1 and this will be the n times the n minus 1. So it might already have these 2 columns in, but if not, add those in and it'll help you organize your information. Then when you go to the simulation, you're going to click on here and you're going to use Produce Community. And what you're going to do is you're going to count how many different organisms there are and how many different species there are. So let's start with the wolf, okay? There is 1 wolf in this community. So you're going to go back up here into your table. Oops. Okay, you're going to put wolf, coyote, whatever it is. There was 1 of them, right? So then n minus 1 is going to be 0, and then n times n minus 1 is also going to be 0, right? So then you're going to go back over here. There were some bugs in the air, okay? I think there were some butterflies, there was rabbit, and you're going to go through and you're going to do the same thing. You're going to count how many organisms there are in the environment. So I'm just going to fill in some numbers. These are not the numbers that match to the website, but we're just doing an example. So we're going to say there's 6. And I'm just going to make up some numbers here. So let's say we got 3 butterflies and we have 2 rabbits. All right. So these are the n's. So n minus 1 would be 5 minus 1, which is going to equal 4. And then we would take n, which was 5, times 4, and that's going to give us 20. So then you come over here. N minus 1 equals 2. So then we would take 3 times 2, which is going to give us 6. 2 minus 1 equals 1. We would take 2 times 1, which is equal to 2. And then you're going to add all of these up. Okay, so we got 20 plus 6 plus 2 is 28. Then you're going to then what we need to do is we need to add up all of the total number of individuals. So this is going to be right here. Okay, so we add 6, 9, 11 total numbers of individuals. And then we would take 11 minus 1, which is going to equal 10. Right, now we can plug this into our diversity index. 1 equals the sum of n times n minus 1 over n minus 1. So we got 1 equals this number here, comes from here, because we added them all up. That's why this is the sum here, right? So we'd get 28 divided by, this should be 1 minus, not equals, minus n, big N, which was 11, times 11 times 10, right? So 1 minus 8 over 110, which would be 1 minus 0.25, which would equal 0.75. And there's our answer. So this number is pretty close to 1, so that's pretty decent because that means that there's a pretty good amount of diversity in it. Now what ecologists will do is that they will figure out the diversity index, and then let's say they'll go back to that environment in 5 years and they'll look at it again and they'll look to see, did the number go up closer to 1? Did the number go down? Is diversity increasing or is it decreasing? And if it is decreasing, what is happening to the environment that's causing it to decrease? So that's why this number is important, is because we can use it as a comparison to see whether or not the environment's getting healthier by increasing in diversity, or whether or not it's not getting healthier by decreasing in diversity. So hopefully this will help you complete your assignment now. You're going to look at some different environments and you're going to see how the environments compare in terms of their diversity index. So the closer to 1, the more diverse, the healthier it is. And then you're going to have to come up with some reasons why you think an environment might be more or less diverse. If you have any other questions, please don't hesitate to ask. Have a great day.